All right, here's such a nice looking problem. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. Welcome to another video on prime logic. We have two identical and congruent semicircles. In one of those, we have two smaller circles inscribed with an area of 4 pi each. So this circle has an area of 4 pi. This one is also 4 pi in area. We have another semicircle exactly similar to this one, and we have one, instead of two, we have one circle inscribed inside. So what is the area of this circle inside? So first things first, the first thing that we have, the only information we have is this 4 pi. So we can use 4 pi to find out the radius of the smaller circles inside. So let's just write it down here. 4 pi equals the formula for circle's area, right? So pi r squared. In other words, r squared equals 4 pi over pi, which is 4. It means that r is root 4 or 2. So let me draw the r here, and because we need to draw some lines on the shape in order to make it easier to understand and find out the radius of the semicircle. So just bear with me a second here. So, okay, maybe this one and also this one. And let me just connect these two centers together. Okay, and also maybe this one as well, and also this one. So I drew some lines, and these lines, each of those segments is the radius of the smaller circle. So each of those have the length of 2. So this one is 2, this is 2, so is this, so is this, so is this, and so is this. So we know that this kind of combined segment is 4, right? But we want to know the value of the radius of the semicircle. So if we connect the center of the smaller circle to the center of the semicircle here, so this is going to be the radius of the semicircle, right? So this length is 2, but if we can find the length, the value of this hypotenuse, because this is a right angle triangle. So if we can find the value of this hypotenuse, then we can combine this segment, and then we find the value of the radius of the semicircle. So we know that this is 2 because this is the radius, and this is also 2 because this line is parallel with this one. So this is also the radius of this smaller circle. So now we have a triangle here. So this triangle here, and it is an isosceles right triangle. So 2 and 2, and then we can find the hypotenuse here. So let's just name it h, for example. So h equals 2 squared, using the Pythagoras theorem, right? So 2 squared, which is 4, plus 2 squared, which is 4, so that's h squared, sorry, and that gives us 8. In other words, 8, which is the hypotenuse, equals root 8, or 4 times 2, root 2. So this little segment here, from the center of the semicircle to the center of this circle inscribed inside, is 2 square root of 2. If we add them together with the radius of this smaller circle, it gives us the radius of the semicircle. So radius of semicircle, let's just name it r, equals h plus 2, right? So h is 2 root 2 plus 2. So that's the radius. So we finally found the radius of the semicircle. And now let's go back to our other shape now. So if I draw a radius here, the diameter here, so we can say that the radius So this is the radius of this circle inscribed, right? So we can see that the radius of this inscribed circle is half of the radius. So this whole thing is also the radius of the semicircle, but the radius of the circle inscribed inside is half of the radius of the semicircle. So in other words, radius of the other, let's say just r sub 2, for example. So it is this one divided by 4, which gives us, okay, 1 plus root 2, because if we divide each term by 2, so square root of 2 divided by 2 is root 2. 2 divided by 2 is 1. So the radius of this circle inscribed is 1 plus root 2. So now after having found the radius, we can just calculate the area. So the area of our circle here equals pi r squared. In other words, pi 1 plus root 2 squared. So let's just, this is a classic identity of a plus 1 squared. So pi, so 1 squared, 1 plus the second term squared, 2 plus 2 times first one times second one, 2 root 2. Area equals pi times 3 plus root 2. And that's the final answer. So the area of this circle in question is pi times 3 plus root 2 root 2. And then I have another chat, so that's going to wrap it up for today. Make sure you drop your thoughts and answers in the comments below, your own approach as well. But let's say we have another challenge here, so maybe 1 or 2 more challenges here. So let me just draw another semicircle here. So here we had 2 circles with the area of 4 pi. So let's say we have, or we had 3 circles here. So 1, 2, and 3. So each with the area of 4 pi. So then what is the value? What is the area of this circle? So then what would it be? Let's say we had another one. So let's just make it a little bit more complicated for those of you who are keen on challenges or bonus challenges. So let's draw another semicircle. So in the previous challenge, we had 3 identical congruent circles. So let's say we had 5 circles maybe. So maybe the shape is not so accurate, but all of these circles, each of those are they are tangent to one another. So each of those with the area of 4 pi. So for those of you who are interested in challenges. So make sure to drop your thoughts and answers in the comments below and subscribe to the channel if you haven't already. And see you on our next video on prime logic.